Alrighty, we are going to be doing the 4A notes today. We're going to start off with a principle that we really already know how to do, but we're going to give it an official name. It's called the addition principle. Basically what it is, as long as I do the same thing to each side of an equation, it stays equal. And we can do this, we add each side by the same thing, they stay the same. And the same thing with the multiplication principle. In the directions in some of the questions, they'll say use the addition principle and or multiplication principle to solve the question. So we're really just introducing that. If I multiply the same thing on each side, it stays the same, and the same thing with division. Now this we'll do a little bit of. We're not going to really focus this much. This is kind of an introduction for something that's really used a lot, to be honest, in Unit 7. And since a lot of us aren't going to Unit 7, I will bring it up, but I'm not going to make a big deal out of it. But if we have an equation with fractions in it, we can multiply by the least common denominator and it gets rid of all fractions. It's a pretty good trick to know. This first thing is kind of evaluating and telling if it's a true or false statement. So we're trying to find out if 35 is the solution. So I let 35 minus 18, and does it equal 19? Well, 35 minus 18 equals 17. 17 does not equal 19. So I think you get a true or false statement here. You get 2 dots to put in. Since this is false, you just check off the false. In the next question, we're going to put 17 in. So it's 4 times 17 minus 5. Does it equal 48? Well, 4 times 12 is 48. So 48 equals 48. So in this time, if I had the true false here, I would click true. And that's all there are. A couple questions. Very simple. Now we have some questions where we got to show the solution here. Now if we remember back in Unit 1, what's the opposite of subtracting 11? Because we always want to solve for the letter. Opposite of the minusing, I would add 11 to each side. And that is an example of the addition principle. I'm adding the same thing to each side. So A is equal to 36, and that's all I got to do. This next one here, it's negative 3 times x. What's the opposite of multiplying by negative 3? Well, I'm going to divide each side by negative 3. So x equals negative 11. And please use your calculators to make sure you're doing all this. Make sure you're keeping the signs correct. Lots of silly sign errors here. Now this next one here, 5 halves x equals 15. This is 5 halves times x, so I'm really dividing each side by 5 halves, aren't I? So if I have a calculator, I really would just type in 15 divided by 5 halves, and I do get x equals 6. This next one is a little bit harder, but this is the one example I'm going to do for finding the least common denominator to get rid of fractions. Because this is really x over 2 minus 1, 2/3 over x minus 3, and that looks awful because of the fractions. But if you remember, if we had the denominators of 2 and 3, the LCD is 6. So what I want to do is I'm going to multiply everything by 6. And if I do that, I'm going to do 6 times x over 2, because remember, I have to distribute it to each thing inside the parentheses. Minus 6 times 1 equals 6 times 2/3 x minus 6 times 3. And so now I just need to do some working out here. If I do 6 divided by 2, that's really 3x. 6 times 1 is minus 6. 6 times 2/3 is just 4x. Please use your calculator to double check me on that. And 6 times 3 is 18. So from here, when I multiply by the least common denominator, this new equation here has no fraction, so it's much, much easier to do. Now I can bring the x's to the left or to the right. Now I'm going to bring it to the left. Normally, a lot of you are saying, no, move it to the right. But I want to overemphasize something. Okay, and I always try to combine my variables first as well. 3x minus 4x is minus 1x minus 6 equals negative 18. So I'm going to add 6 to each side. Then I'm going to get negative 1x. I'm going to bring it up here. Equals negative 12. So remember, this negative 1x, I really got to divide each side by negative 1. So x equals positive 12, and that's my answer. There won't be too many of these questions, but I wanted to introduce the least common denominator trick there. This next one, you're going to see the questions in this section. They're going to have three possibilities if you look over to the right here. And what you're going to end up doing is you're just going to check off, just like the true or false buttons. If you come up with x equals numbers, you're going to check this off, and then you're going to write in the answer. Okay, for that last question, we have x equals 12. So I would just write x equals 12 into the box. Okay, so I have an issue here. Can't get it out of the box. Okay, we're back. Sorry about that. Alright, so now, like I said the last question, I always try to connect my x's first. So I'm going to try to bring these on the same side. So I'm going to subtract x. What happens on here, x minus x is 0, it's gone. X minus x is 0, so my x's have disappeared. I'm left with 12 equals 12. Now, when the variables disappear, it's either going to be one of these two possibilities. The solution is all real numbers, or there is no solution. Now, 12 equals 12 is always true. So if my x's go in and I get a true statement, it is the all real numbers. On this side here, when I take away x from each side, again, all the x's go away, so I'm left with negative 21 equals 5. Now, negative 21 can never equal 5, and this is one no solution. They love to throw in these questions, and please be careful on that. If it's a true statement, 12 equals 12, everything is right, so all real numbers works. If you get negative 20 equals 5, that will never happen, and that's why there's no solution. This next one here, we're now starting to bring in a couple different units here. Unit 3, we learned how to distribute. I'm going to distribute the 2 to each one of these. 2 times 3 is 6. 2 times 4m is 8m. Minus 9 equals 45. I always try to combine like terms first. Now the 8m, there is no other like terms, so I'm just going to write 8m. 6 minus 9 is negative 3 equals 45. Remember, if they're on the same side, 6 and negative 9, I just combine them. It's when I want to move it to the other side of the equation, that's when I do the opposite. So right now I want to move this 3 to the other side of the equal sign, so I have to do the opposite, so I'm going to add 3 to each side. So I get 8m equals 48, divide each side by 8, I get m equals 6. This is another review of Unit 3. We have this minus sign out here. I am not distributing the 5r. Remember, this is an invisible negative 1, so I'm really multiplying each one of these by negative 1. So this is 5r, negative 1 times 2 is minus 2r, negative 1 times 8 is minus 8 equals 16. Again, I combine my like terms first. 5r minus 2r is 3r, minus 8 equals 16. I'm going to do the opposite because I'm moving it to the other side of the equation, so I do the opposite. 3r equals 24, divided by 3, I get r equals 8. Alright, so now, there's nothing on either side that I can combine. This has an x, this does not have an x, and both sides have a real number without a variable, and then the x variable. So, I'm going to want to bring this minus 54x over to the other side of the equation. So what's the opposite of subtracting? I'm going to add 5.4x. 3.4 plus 5.4 is 8.8x. Minus 4.32 equals 2.72. Now the minus 5.4 plus 5.4 cancels. That's the whole point. So if I want to bring this minus 4.32 to the other side, I have to do the opposite, so I got to add 4.32. And so when I add that up, I get 7.04 equals 8.8 x. Almost forgot the x. So 8.8 is attached to, so I have to divide each side by 8.8. I type this into my calculator at x equals 0.8. Now, I kind of did this one, negative x equals 24, a little bit ago, but I wrote it a little bit differently. I'm going to sneak back up there for a second. It's right here. I have negative x equals negative 12. Now, it's negative 1x, but in this question down here, they don't write the 1, do they? They just have the negative x. But this is really negative 1x equals 24. So how do I get rid of the multiplying by negative 1? Well, I divide each side by negative 1, and I get x equals negative 24. This is amazingly how simple this question is, but I can't tell you how many people get this one wrong. Be careful. All right, and the last question for this section, that's a pretty fast one. We're going to be under 15 minutes on this. So I need to get rid of the parentheses, so I need to distribute the negative 2 to each one of these. So negative 2 times x is negative 2x. Negative 2 times negative 5 is plus 10. Plus 10 equals, now I got to distribute the negative 3, get negative 3x minus 6 plus x. And as always, I'm going to combine things on the same side. Now 10 plus 10 is on the same side, so I don't do opposite, I just add it together. So it's negative 2x plus 20. Here, the negative 3x and the x are on the same side, so I don't do anything opposite. I just add negative 3x plus x, which is negative 2x. Then I subtract 6. And as always, I try to get the x's over first. So I'm going to add 2x to each side. And now that cancels, and that cancels. So the x's are gone. I'm left with 20 equals negative 6. And if you remember, that's a false statement. So the answer is no solution. Okay. And that is Unit 4A notes. Very quick. This is usually a good one. Good luck. And that's the end of this one.